Hi, one of the most talked and symbolic icons of nanotechnology is carbon nanotube, and there are some reasons behind the extensive amount of attention to carbon nanotubes. If you remember, we have classified nanotubes as the one-dimensional nanostructures, and carbon nanotubes is one of the famous allotropes of carbon actually. I'm sure you already have heard about carbon nanotubes and of course discussion or research being done about carbon nanotube based features and systems to be used in a variety of applications, even that crazy space elevator made by carbon nanotubes. If you are curious to discover more about carbon nanotubes, in this lecture I'm going to talk about carbon nanotubes, about their structure, what makes them so attracting, about their unique properties, and of course some of the exciting applications to be fulfilled by carbon nanotubes. I'm Milad, your instructor from Bright Vision Academy. Bear with me. Definition and structure. Carbon nanotubes are tubes, or let's say cylinders, made of carbon atoms with diameters typically measured in nanometers. Although not made this way, but we can imagine carbon nanotubes could be formed from graphene sheets. As we saw in the previous lecture, graphene is one atom layer sheet of carbon atoms bonded in hexagonal network. And if we cut through that sheet, we get graphene nanoribbons. And if you roll up that ribbons throughout the length, basically what you are making is a carbon nanotube. Although carbon nanotubes are not made this way in practice, but that's a nice picture to have in mind actually. One of the first things that comes in mind about making carbon nanotubes from graphene is the cutting orientation, because depending on the cut orientation, different forms of carbon nanotubes are obtained. Let's make it more clear by this picture. If I cut graphene in this direction and then roll it up from the other side, my carbon nanotube gonna have zigzag edge, and because of that, this form of carbon nanotubes are called zigzag carbon nanotube. If I cut graphene through this direction and roll it up through another vertical direction, what is concluded is so-called armchair carbon nanotubes regarding the edge of the tube. And also there is another possibility which results in neither zigzag nor armchair, and those kind of carbon nanotubes are named chiral carbon nanotubes. Furthermore, there are a couple of options, and also carbon nanotubes could be larger or smaller depending on how much wide we cut through the graphene. All in all, there are a couple of options, and we need to think about a naming method to keep carbon nanotubes recognizable. It actually is done through defining the roll-up vector of lattice Ck, which is equal to Na1 plus Ma2. A1 and A2 are so-called lattice vectors, and N and M show how many times these vectors are repeated through, for a specific carbon nanotube. Well, how is it working? A1, as shown here, is a vector representing moving one step through this zigzag line of graphene sheet, and N shows how many times this A1 vector is repeated by our cut from the sheet. About another lattice vector, A2, A2 is defined with respect to A1, representing oriental zigzag movement like this. And M shows how many times this one is repeated. So, for example, if I want to make a zigzag carbon nanotube, I cut graphene by this vector and roll it up by the other side, right? In this case, I have repeated vector A1 10 times and no repeat of vector A2. Here the notation in parentheses is gonna be like 10 zeros. Under this notation system, zigzag carbon nanotubes have always M equal to 0 and N should have some value. Regarding armchair carbon nanotubes, N and M are